Welcome. This video is going to talk about something called the law of definite proportions, which is a little bit different than the law of multiple proportions. The law of definite proportions says a compound is always composed of the same elements in the same proportion or ratio by mass. So this means the mass of the compound is going to equal the mass of each element in the compound added together, or what we call the molar mass. And that once you look at those individual masses compared to the whole mass, or what we call the percent mass, if the percent masses or mass proportions are the same for two compounds, then those two compounds are the same compound. And I know it's a little bit confusing, but for example, what this means is water is always two hydrogen atoms with one oxygen atom, or has the formula H2O. And we can do that by looking at the mass proportions. And to do that, we have to get water's molar mass. So we add up the mass of two hydrogen atoms with the mass of one oxygen atom. And we do that by looking up the mass of each on a periodic table. So if you find hydrogen on your periodic table, you're going to need the molar mass for hydrogen over at number 1, and then find oxygen number 8. And you'll need to set up a percentage for hydrogen and a percent for oxygen. And remember, whenever you're finding a percent, which we do a lot in chemistry, it's always the part you're interested in divided by the total times 100%. And all your parts should add up to 100%, or within a few 100ths of a. So to find the mass proportion, or percent by mass, of hydrogen and oxygen water, I first need the molar mass of water. And water has two hydrogen, and if I look on my periodic table, it has an average mass of 1.01. The label for that is grams per mole, although we're not too concerned about that right now. And then I find oxygen over at number 8, and I just have one oxygen, and I see its mass is 16.00. You should keep 2 decimal places when you're working with atomic masses. And so this would give me a molar mass of 18.02. And again, my label is grams per mole for my water. So my percent of hydrogen, water is 2.02 grams out of 18.02 grams. And if I take that times 100%, and again, I'll keep 2 decimal places, I would come up with hydrogen being 11.21%. And if I'm confident, I could just subtract that from 100 to get my percent of oxygen, or I could put 16, the part of oxygen, out of the total, 1802, and take that times 100%, and I do get 88.79%. So now if I have an unknown solution that I know contains hydrogen and oxygen, if I can find out the percentage of hydrogen and the percentage of oxygen in there, I'll know if it's water or not, because if it's water, it'll be 11.21% hydrogen and 88.79% oxygen. So here's an example. If you had a liquid that weighed 5 grams and 0.3 grams of this mass is hydrogen, is it water? Why or why not? Well, remember, we know that water is always 11.21% hydrogen. That's what the law of definite proportion tells us. So I can use this data to calculate the percent by mass of hydrogen in this sample and compare it to this 11.21. So I'm going to do exactly that on this next slide. So 0.30 grams is the hydrogen. 5.00 grams is the total. So if I set up my percentage and I go ahead and punch this in, I see that my percent is not going to be 11.71 or whatever it was. Instead, it's only 6%. So no, this can't be water. The percents don't match. Okay, it's some other substance with hydrogen and oxygen in it, but it is not water. And that's what the law of definite proportions lets you do. You can compare substances. If they have the same proportions, you can conclude they are the same substance or same compound.